We have covered quite a lot on session hijacking. Can session hijacking be done in passive mode or only in active? It can be done in either passive or active modes.
A passive mode attack often employs techniques to sniff user IDs and passwords. And then with that information, the attacker could really log in as a genuine user and do whatever he wanted to. Now, there are ways to prevent passive attacks. Some of the prevention techniques include using one-time passwords, security keys, etc. These will help to some extent if encryption is not used, and these will not help in an active attack. So encryption is the key that you need to remember or consider here.
Yeah, and in an active attack, the attacker takes on an active role. He could tear down a part of the session and assume control. He can play the man-in-the-middle attack. We already talked about ways to predict the sequence number used.
Now, we're going to introduce you to the different types of session hijacking. You have application-level hijacks, cross-site scripting hijacks, network-level hijacks, and protocol-based hijacks. Now, we're going to take a look at each of these in turn.
In a session hijack attack, a session ID that is stolen or predicted is used to gain access to a target. When one applies application-level hijacking, he or she employs network hijacking as well. Network-level hijacking provides a lot of useful information to carry out application-level hijacks, so attackers normally use these together.
Now, application-level hijacking involves either taking control of an existing session or perhaps even creating a new one. The attacker would use stolen or predicted session IDs to do so. Application-level hijacking normally happens with HTTP sessions. Now, these could be hijacked by getting the requisite session IDs. Application-level session hijacking can be carried out by predicting session tokens, man-in-the-middle attacks, client-side attacks, man-in-the-browser attacks, and session sniffing.
We have talked about predicting session tokens, but now we are going to spend some time on predicting session IDs. You want to predict future session IDs and use them to hijack a session or imitate a website. You could speculate the ID based on the pattern of session IDs. And when a user tries to log in to an application, he will be required to provide a user ID and password. When these are verified, a session ID gets generated.
And that session ID is sent, and the session ID shows the client session as confirmed. The session ID is tagged to all subsequent communications between the client and the website and confirms that the session is a valid one. If the attacker can predict or guess the session ID, then he'll be able to hijack the session, right? As I mentioned, session IDs are then calculated using simple complex algorithms. The attackers observe the session IDs to find the patterns and then predict the session ID.
Yeah. A man-in-the-middle attack is very interesting. The intruder gets in between a valid session and decides what to do. The data packet exchanges possibly happen through him. The attacker would split the connection between two parties into two halves. One between the victim and him or her, and the other between him, her, and the host. These parties don't know that the packets are going through a different party. The attacker can snoop the data, intercept messages, and inject malicious data.
Now, a client-side attack, the attacker tries to make use of the vulnerabilities present in client applications. So he will force the client to communicate with a malicious server, and he may force the client to process malicious data. This kind of attack takes place when a client tries to interact with a server. If the client does not interact with the server, this attack will not take place, right? As the server cannot send the malicious data or instructions to the client. Now, you can have client-side attacks in three possible ways. They are cross-site scripting attacks running malicious JavaScript code, and then the third being the use of a Trojan.
Now, a man-in-the-browser attack is similar to a man-in-the-middle attack, but they're different. The difference is that the man-in-the-browser uses a Trojan horse program to catch and control the session between the browser and the security components or libraries. The attack is capable of sniffing transaction data and can even modify the data. The attacker's primary target is to steal money, sensitive information, etc. Now, when this happens, they may not even leave a trace of the attack. Even if you're using SSL to transfer data, you cannot escape if a Trojan has been installed. Users will have to be cautious when using machines.
Very, very cautious. So we're going to talk about one more application level attack. This is session sniffing. Session sniffing is really an easy one to do if data transfer happens without encryption. Again, encryption is the key here, folks. The data may contain the session ID. The attackers will make use of sniffers to monitor the HTTP activity and try to get session IDs. It's impossible, or it is possible, that the packets may contain user IDs and passwords. The attacker can then use this information to take over the session. There's a lot more to learn about this topic, really, but we just need to move on to cross-site scripting, I think.
Now, while talking about client-side attacks, we mentioned cross-site scripting attacks. This is a user-side attack. The attacker uses malignant code to get the session ID. Here, a malicious client-side code can be injected into web pages, and you may bypass security controls. The attacker may lure a targeted victim to click on the malicious code. Once a targeted victim clicks on this, the instructions defined by the attacker will be executed, and there starts the attack.
That's right. Now, like we talked about, application level attacks, we've mentioned the network level attacks happen in conjunction with application level attacks. Information provided by network scans or attacks will be used in application level attacks. Network level hijacking includes blind hijacking, RST hijacking, UDP hacking or hijacking, man-in-the-middle hijacking, TCP/IP hijacking, and IP spoofing. Blind hijacking involves predicting the sequence numbers and then sending session start requests to the target. The attacker is going to keep sending these requests, and he won't be able to see the responses. So he sends further requests based on expected responses, and will try to make sure that the session is not terminated. He wants to keep it going, keep it active.
Now, RST hijacking is a type of TCP/IP hijacking. Here, an RST packet is injected. The attacker first sniffs the connection data between the source and the destination. The attacker then creates an RST packet with that of the source address and acknowledgement number of the genuine connection. When the victim receives the RST request that appears to have come from a genuine source, it will reset the connection then.
That's right. Now, let's talk a little bit about a UDP. UDP does not utilize packet sequencing and synchronization. This means it's going to be easier for an attacker to hijack UDP sessions. In a UDP attack, the hijacker creates a response to the client even before the server responds. So he's developing what he's going to say. The answer from the server could be limited. Now, you can use a man-in-the-middle attack to stop the server's responses to the client.
Yeah, and man-in-the-middle uses a packet sniffer to capture the exchange of packets between the client and the server. The attacker changes the default gateway setting of the client's system with a view to route the packets through the hijacker's host. Here, the ICMP packets are forged to divert the traffic via the hijacker's host. When the packets are routed through the attacker's host, he or she can sniff them. You can also use address resolution protocol spoofing. The ARP table is used to map the local IP addresses to MAC or hardware addresses. The attacker sends forged ARP replies to update ARP tables. The packets sent to that IP address will now be sent to the host.
TCP/IP hijacking uses spoofed packets to gain control over a connection between a victim and a host. The victim and the attacker are on the same network, and then the host can be anywhere. So we're going to see more about TCP/IP hijacking soon. IP spoofing is used to gain unauthorized access to computers. The attacker gets the IP address of a genuine client, modifies the packet header to make the target believe that the packet is from a trusted IP address. And then here the sender specifies the path to the destination IP. Once he gains entry into the session, he works to desynchronize the session between the victim and the host by sending forged packets.
TCP/IP hijacking uses spoofed packets to gain control over a session between a victim and a target computer. Systems that use one-time passwords and security keys can also be attacked through this technique. The attacker first sniffs the victim's sequence numbers. Using these numbers, the attacker sends a spoofed packet as though it is from the victim's system or IP to the target system. The target believes that this packet is from a trusted source.
Sure.
It acknowledges the victim's IP after incrementing the sequence number. The victim is unaware of the packet sent by the attacker, so it cannot recognize the packet and just simply ignores it. It turns the sequence number count off. The host receives packets from the victim with incorrect sequence numbers. This way, the attacker forces the sequence numbers to go out of sync, thereby forcing the session to quit into a desynchronized state. The attacker attacks the packets from the victim and continues to spoof and communicate with the host machine. During this time, the victim's session hangs.
That's right. Bad news.